We've gone over improper integrals that are improper because of an infinity in the boundaries, whether it be positive infinity or negative infinity. What we're going to look at now is improper integrals that are improper because of discontinuities. Remember, one of the rules to be able to take the integral is that your interval, the boundaries here, for example here at 0 to 1, not contain any discontinuities. But today we're going to learn how to work around that. So for this first example, we've got the integral from 0 to 1 of 1 over the cube root of x dx. Now, if you notice, we would have a discontinuity at 0 because that would create a 0 in the denominator and we can't divide by 0. So, we have a discontinuity at 0 and we're going to do something very similar to what we did with the infinities. We're going to replace that 0 with an a, and we're going to do the limit as a approaches 0 from the right. So we do have to do a one-sided limit for these. And here's the reasoning behind that. Let's imagine a number line, and we're going from 0 to 1. So this spot I'm going to highlight in blue is the only spot we're looking at. It's the only thing we have to go on. So here's us. We're between 0 and 1. The only way we can approach 0 is from the right side of 0. So we're approaching it from the right. Anytime you replace the 1 on the bottom, it'll be from the right. Anytime you replace the 1 on top, it'll be from the left. If you can just remember that, you'll be good. I find the number line helpful if you aren't sure, but that's up to you if you want to use that or not. So now we can take the antiderivative, add 1 to the exponent, divide by that number. Then we plug in the top, limit as a approaches 0 from the right, 3 halves, 1 to the 2/3, minus 3 halves times a to the 2/3. Okay, so I get 3 halves minus, if I plug in 0 for a, I just get 0. So the answer is 3 halves. You're welcome to test that in your calculator. You could plug this right here into y1, and then you could do the limit as a approaches 0 from the right, so you would plug in things like 0.1, 0.01, 0.001, and so on, and you should get it getting closer to 3 halves. Okay, next up we've got the the integral from 0 to 2 of dx over x minus 2 cubed. Now this time the 2 is going to cause the problem. 0 is fine. You can do 0 minus 2 and then negative 2 cubed. No big deal. But 2 on the other hand, can't do. So we do the limit as b approaches 2 from the left. Integral from 0 to b. And I'm going to bring the x minus 2 up top and get this. Now you don't really have to use u sub here, but we'll do it just to be as clear as we can. Okay, so no adjustments needed. So we get u to the negative 3rd du. Add 1 to the exponent, divide by that number. We get negative 1/2 u to the negative 2. So that's going to end up being negative 1/2 x minus 3 to the negative 2. And then I'm going to go ahead and plug in, x minus 2, not x minus 3. There we go. I'm going to go ahead and plug in the b. Minus, plug in the 0. So I get minus a negative 1/2 is why I have that. Okay. This one's probably just going to be simpler to do in our calculator. So let's pull that up. Go to our function. We have negative 1/2 x minus 2 to the negative 2 plus 1/2 times 2 to the negative 2. Just double check I've got everything right. Looks like I do. Okay, so remember we're approaching 2 from the left, so we want to plug in things like 1.9 and 1.99 and 1.999. So it appears that we are heading towards negative infinity in this case. So we diverge because we're going toward negative infinity. Our final example, we have the integral from -1 to 2 of 1 over x cubed. Now what's different about this one is we still have a discontinuity, 0, but it's not one of our boundaries. It's actually in between our boundaries, and that's still a problem. We can't have a discontinuity in between the boundaries any more than we can have it on the boundary. But we can't pull it out if it's not one of our boundaries. So similar to what happened when we had a negative infinity and a positive infinity, we have to split this into two pieces. So I'm going to do the integral from -1 to 0 of 1 over x cubed dx plus the integral from 0 to 2 of 1 over x cubed dx. And here it is important. You've got to split it at the 0 because the 0 is the discontinuity you're trying to get rid of, or trying to deal with anyway. So I get the limit as b approaches 0 from the left right here. I'm going to go ahead and rewrite the 1 over x cubed as x to the -3. And here I'll get the limit as a approaches 0 from the right. So we get that. Now, we add 1 to the exponent, divide by that number. Do the same thing for the second integral. It should be the same integral, so -1/2 x to the -2. Now we plug in the top. Sorry, this should be an a, my fault. A to the -2 minus a -1/2, 1 to the -2, plus the limit a approaches, b is where I should be. I'm sorry, it doesn't really matter what letters you're using, but good to stay consistent. Limit is a approaches 0 from the right of -1/2, 2 to the -2, minus a negative, so plus 1/2 a to the -2. Okay, so I've got to do these two separately because it's two different limits. So let me pull up the calculator. For this first one, we'll have -1/2 times x to the -2 plus 1/2 times 1 to the -2. And I want to see what's going to happen as I approach 0 from the left. So it'll be -0.1, -0.01, -0.001, and so on. It appears very clearly we're heading toward negative infinity, which you can pretty much stop there and know you're going to diverge, but we'll go ahead and do the other half just to make sure. Let's see, here we go. I'll just pull this over here. This time it's -1/2 times 2 to the -2 plus 1/2 times a to the -2. Okay, that's it. And then we're going to approach 0 from the right, so it'll be positive 0.1, 0.01, 0.001, 0.0001, and so on. And that's going towards positive infinity. So it's clearly diverging in this case.